So in our last unit, we talked about ratios. That was any time you could refer to one thing compared to another thing within a same system. Or fundamentally, a ratio is just a fraction. So if I have a fraction like I had two, let's bring back our party. It took 2 pizzas to feed 8 of my friends, so 2 pizzas to feed 8 people. That would be considered a ratio. It's a ratio of the number of pizzas to the number of people. Now, proportions, we start to build to a very powerful tool in mathematics and in real life, in fact. One of those maths students often ask, how will I ever use this in the real world? This is one of those maths that you will find useful in the real world. So let's look at, what is a proportion? Well, it's a ratio, and I'm going to use letters here. So this would be a ratio. A over B, A pizzas to B people would be an example. A full cans to B half cans, half filled cans. And if I took another ratio, C over D, whoop, that looks like a B to me, C over D, and set them equal to each other, I've actually created a proportion. So that's exactly what a proportion is. It's two ratios that are equal to each other. Okay, so if I said 2 pizzas and 8 people is equal to 2 over 8, that would be a duh factor. But if I said that 2 over 8 is equal to, check this out, 1 over 4, isn't that true? Even though they look different, they're true statements. And so we're going to work with that for this next unit in preparation for the powerhouse of this chapter. So let's look. No more explaining to do. A proportion is two ratios set equal to each other. That's all the explanation you need. But we're going to use that truth to solve for some unknown values. So if I'm given 5/6 is equal to, well, in this case 18, but x over 18, these two proportions are equal to each other. So I can certainly solve to find out what x is, because whatever the relationship is, x has to have a value that is equal in this situation. So we know how to do this, correct? We know how to do this. We can look at it a couple of ways. One is we can just go ahead and solve it. Yep, we can say that x, well, first I like my variable on the left hand side. Haven't changed anything, just flipped it over to the way I like to look at it. And then I can see that I want to get x by itself, so I'm going to turn my divided 18 into a multiplied 18 on the other side. I'm going to do the opposite operation for multiplication and division. And now I can just do some simple reducing. I have factors of 8, a factor of 18 in the numerator, a factor of 6 in the denominator. Well, 6 divided by 6 would leave a 1 in the denominator. 18 divided by 6 would leave a 3 in the numerator, and I can multiply these together to get 15. Okay? Now, when you read your book, it's going to do something a little bit different. All right? It's going to play around with some semantics. So I'm going to show that to you. But the truth is, most of the time you're going to want to solve these directly the way I just did. So let's start again. I'm going to take 5/6 equals x over 18. And so in the book they show you that you want to ask yourself, what do you have to do to 6 to get 18? Because if these two ratios are equal to each other, that means the denominators have to be equivalent and the numerators have to be equivalent. And so the question is, what would I have to do to 6 to turn it into 18? Well, I would multiply by 3. So if I do the same thing to 5, multiply by 3, I discover that x equals 3. So notice I did the same thing here, 5 times 3, I did reducing. Either way, one is a visual way of looking at a proportion to solve it quickly in your head, and the other is when it's a simpler proportion, and the other is doing algebra. And I'm kind of into the whole doing algebra thing. So let me give you a few examples to practice. 2/7 equals x over 21, and I don't really care which method you use, the one in your head where you can just look at it and figure out what x is, or the one where you solve it. Both are good for me at this stage of the game. So 3/8 equals x over 32. Number 3 would be x over 2 equals 20 over 10. And 4 is x over 48 equals 6 over 12. Okay, so let's do an example, a real world example, because that's where these are really useful. Yesterday you rode your bike 18 miles in 2.5 hours. And so remember, 18 miles in 2.5 hours is a rate. We dealt with this in our last section. Today you plan to ride 3.5 hours. If you ride at the same time as yesterday, how far will you ride? So this is a word problem. First thing you have to identify is what is the thing you're looking for. And in this case, the question they're asking, or the thing you don't know, is how far will you ride? So let's give that a variable of x, and let's go ahead and put miles in there. So x miles, we're looking for x. We want to set up a proportion using the information from yesterday, because it says if you ride at the same rate as yesterday, how far will you ride? We want to set up a proportion that lets us solve for x. So your book uses a block or a grid method, perfectly fine method, not the one I really like. The one I really like is the one that you can use forever in the real world, especially when you get to geometry. You will use it a lot. It has to do with similarity. We'll do a little bit of that even in this unit. So let's set this up using the language that I find the most useful. Okay, so we're going to say the miles per hours in one situation has to be equal to the miles per hour in the other situation. So one day you had miles per hour, and then the next day you're going to have miles per hour. So if we set the ratio up where you have two things that are clearly equal to each other, we can start to get at this value. So let's look at yesterday's situation. So we're going to identify this as the yesterday, and we're going to identify this side as the today. And so we want to keep all of our information from yesterday, and all of our information for today. So let's set this up. Well, yesterday you did 18 miles in 2.5 hours. That was yesterday. Today you're going to do, well, remember, x miles is the thing we don't know. Some number unknown of miles today in today's time is going to be 3.5 hours. Okay, so now you have a proportion, and I can solve for x. First thing I want to do, obviously, is get my x on the left-hand side, because that's where I like it. In fact, in all honesty, I tend to set these up where my unknown is on the other side. But I didn't plan ahead as much because I was thinking about teaching you rather than just solving the problem, so it's okay. I can fix it at this stage. 18 over 25. So I want to get my x alone. That means I'm going to multiply 3.5 to both sides. So x equals 18 times 3.5 over 25. And let's see, x is 2.52 miles. So word problems, if you get the problem in words, you have to give the answer in words. So the answer would be, I will travel, or I will ride just over 2.5 miles today. Okay. All right, so I want to show you something else, just a little factoid, just in case you run into a situation where you've done this and you think, eek, this is a problem. What if I set this up, this proportion here, I chose 18 miles in 2.5 hours. But what if I had set it up instead where I wrote hours in the numerator and miles in the denominator? Totally allowed, right? Totally allowed, because I know that in my first ride yesterday, 2.5 hours was equal to 18 miles. Okay, so since it's inside of one system, it was all what I did yesterday. I'm not mixing things up. I'm looking at one situation and taking those values. Then I can set up a fraction that has one value in the numerator, or I can set another fraction up that has the other value in the numerator. The only thing I have to be sure I do is on the other side of the proportion, I can't write miles on top and hours on the bottom. Can you see how that would be a bad thing, right? I can't mix my things. I'm comparing hours to hours and miles to miles. So I have to undo that. Sorry, I know erasing is harder when you take notes. And change this to, excuse me, hours and miles. Okay? And this time, I'm not going to make the same mistake I made before. Because I know the unknown value is in today, I'm going to put my today on the left-hand side right away. And then yesterday. And now I'm going to use the language that we normally use with math. Okay, so I'm going to say hours today is to miles today. See, hours today is to miles today, in the same way that hours yesterday is to miles yesterday. So we say hours is to miles as hours is to miles. But look what I did here. I made a big mistake. I put my x in the denominator. All right, we don't like it there, but we know how to handle that, right? We have an x in the denominator. The first thing we know we want to do is get the x's in the numerator. So I can get rid of this x by transposing it to multiplication on the other side of the equals sign. Okay, and look what I've done. I put my x on the right-hand side anyway. So I'm going to go ahead and flip it back over. So x times 2.5 divided by 18 equals 3.5. Okay, then all I have is x times a fraction, so I'm going to say x equals 3.5 times the reciprocal of this fraction. So 18 would be in the numerator, 2.5 would be in the denominator, and look what I have. I should have exactly the same thing. 3.5 times 18 in the numerator, and this would be just like that, multiply across, and 25 in the denominator. So I get the exact same answer, 2.52. So it takes practice to set it up where you have your variable where you want it to begin with, but it doesn't matter. You have algebra. You know how to move things around if there's an equal sign. Just move things to where you want them and solve them at that point. Okay, so let me give you one to practice for homework. Actually, I'm going to give you two to practice for homework, and they're both in your textbook. So what number are we on? 5? Yep. So for number 5, I want you to go to your textbook page 277 and do problem number 8. And then flip the page for number 6, flip the page and go to 278. And do problem number 25. And so those are the problems I want worked when you come to class tomorrow. And let's see. Is there anything I forgot? No, I think we're good to go. I'll see you in school.